Hi everybody, I'm going to show you parallel and perpendicular lines using technology just so you can kind of see how we could measure the angle and determine when things are parallel, perpendicular, or neither, right? That's always a choice as well. So I'm going to start by using y equals 4x plus 1 and y equals 4x minus 3, and I'm just going to go graph them in GeoGebra and show you what it looks like. So I'm in a particular GeoGebra, I'm in Geogebra Geometry because it has some other tools that I want to use. So I just turned the grid on and I'm going to go to the algebra, and algebra is where it lets me put in my equations. So hopefully you're not surprised by the graph of this. You have two lines that are not touching. So let's try another one that we can't really tell when we first look at it for sure if things are parallel, perpendicular, intersecting. So I'm going to graph 3x plus 2y is 6 and 3x minus 2y is 12, and I'm going to graph it exactly like that. I'm not going to put it in slope-intercept form. So what we can see is definitely these are not parallel. We can see that there is an intersection point for these two lines. So I'm going to go to Tools, and I'm going to go down to Measure Angle. So I'm going to click on one line, I'm going to click on the other line. So what it tells me is at least one of the really two angles that are happening here, right? The ones across are always going to be the same. So it says this one is 67.4 degrees. If you want to check this the other way, sometimes it helps to put some points on the line. So I'm going to put a point here, I'm going to put a point here, I'm going to put a point at the intersection, and that just gives a little guidance to it picking the angle. So I can click B, C, and then A, so it knows what I'm measuring. It's hard to see there, but it says 112.6 degrees. I could turn that other one off, trying to kind of unclick it so it doesn't show, and let's move that over so now you can see it's 112.6. So definitely not 90, which is what I wanted to show you. So to give you a view of what it would look like if it did come out to be 90, I'm going to change the second equation. I'm going to make it y equals 2/3 of x plus 4. So again, I see that these are intersecting. I'm going to go back to my tools, kind of go down to the angle, and I'm going to click on these, and you can see it's really pronounced that that's at 90 degrees. So when things are perpendicular, it'll pop. I think it's important to see that we kind of used to use technology or go back to looking at the actual lines and look at the slope to determine if things are perpendicular or not. Sometimes it's hard to tell just by sight if things are intersecting in a 90-degree angle or just intersecting in general. This first line, if you solve for the slope, you would have a slope of -3/2. Then the negative reciprocal is positive 2/3. So you kind of have to be careful with this. You don't want to just trust yourself by looking at things. You really do want to see it. So I'm going to show you that really quickly one more time to say, like, if I had 4x, because that's kind of small, what's the negative reciprocal? It would be -1/4 and then times x. That's where the 90 comes from. So you need the numbers to be both reciprocals and have opposite signs, and then that will bring in that 90-degree angle that we talked about.